So now we've got the second part of case study ex3, and we've got a new set of operations to talk about, operators to talk about, including things like collect and reduce that we've talked about but haven't really looked at in detail in a case study. And there's also, of course, a bunch of mono operators that we use here in conjunction with these things as well. So once again, you can find this in the ex3 folder, in the ex3 project rather, in my reactive Flux folder, in my live lessons GitHub repository. So here we are back in the live lessons GitHub repository. Before we'd taken a look at the exception handling operations, now we're going to take a look at a bunch of ones that do other kinds of multiplication operations using various methods that are part of Project Reactor's Flux, especially some new methods that handle combining. So let's go ahead over here and we'll start by taking a look at test fraction multiplications 1. And this is also going to show up a couple other methods we talked about as part of this overall section, beginning with the Flux generate operator. So if you recall, remember, generate generates an endless stream of values that are part of the Flux. And in this case, what we're doing is we're going to generate big fractions. So we're going to make an unlimited number of said big fractions using our make big fractions factor method that we've talked about many times. But because we don't want to use up all the computations forever, we're going to use a suppressing operator called take to stop after generating a certain number of these things. So after generating max fractions of these things, which I think is probably 10, we'll stop. And what we then do is we use our good friend, the flatMap concurrency idiom, to go ahead and reduce and multiply each of these big fractions. You can see we do this basically in the background using the scheduler that's passed in, which is the parallel scheduler. And we take the results of that and we collect these results into a list using the toList method. Probably could have used another method just for fun, but I used toList here. And then we take the results of that and we sort and print the list. So I could have used collect list, would have had the same behavior, but I wanted to show off how you could use collect instead. Let's go take a look at another way to do this. This is called test fraction multiplications 2. Rather than using the generator factor method on Flux, this time we're just going to use the fromArray factor method, which takes this array of big fractions and turns it into a Flux stream of big fractions. Once again, we go ahead and use our flatMap concurrency idiom to multiply each fraction using the parallel thread pool. Except this time, what we're going to do, just for fun, is we're going to go ahead and use the reduce operator. Reduce is a combining operator that takes the stream of multiplied fractions and goes ahead and will add them all together by using the big fraction add by function. And so, let's see, what kind of thing is this? Yeah, so it's going to use the add method. And so it's going to combine those together. So what we do in that case is after we're done adding them all together, we then go ahead and display the result, which will just be a single result. And then we return a monitor void, which is a flag to the async task barrier framework that says, hey, guess what? This is going to be a completed asynchronous operation. So the third and final approach here is we're going to call Flux generate. Once again, we're going to take only a certain number. Once again, we're going to multiply and reduce and multiply each of the elements concurrently using the flatMap concurrency idiom. But this time, we're going to use a different method called collect multimap. And the collect multimap is going to end up collecting the results into a map that's going to have a big integer for the numerator and a big integer for the denominator. And so we're going to make a hash map of these elements, and then we're going to go ahead and print that map. So if you can see, take a look at print map. What that does is it goes ahead and it iterates through every element in the map, and it prints out the results. So let's go ahead and run this particular test program. again. And since we're using random number generators, each run will produce something slightly different. And you can see we have 3 results. Here's test fraction multiplications 1. And these are the gargantuan results we get from that. And this is what happens after we sort them. We do test fractions multiplications 3. And you can see, again, we generate some big results, and then we sort them. And so, and you can also see that this is kind of fun. Test fraction multiplications 2 was called after test fraction multiplications 1, but because it was doing a much simpler, faster set of computations, it finished first. So, of course, because of the inherent non-determinism of concurrency and asynchrony that we're using here, we were able to get those results printed before the ones for test fraction multiplications 1. So those are basically the results that we have got here. And you can see this is printing out the numerator followed by the denominator for each of the elements in that map. So that's the end of the discussion of this case study. And at this point, you should have a very good understanding of all the various operators that are in Project Reactor Flux, as well as some of the ones that are in Project Reactor Mono that are most commonly used in practice.